This section, we're going to continuously talking about a little bit more on the functions. Some of the definition here, it's they want us to go over it, like for example, finding even and odd, right? And then intercept, and then the symmetry, right? This is stuff that we went over from the previous. We're going to see if we be able to do that from the function given. So the first one is asking to find if the given function f of x, which is cube root, right? Cube root. They wanted to see if this cube root given is the even or odd functions. So how do we tell that? Well, we're going to replace x with negative x and see if we end up getting function back, what we started back, right? If we get what we started, it's going to be even functions. If we end up getting negative of that f of x functions, then it's going to be odd. So when we replace x with negative x, we end up getting negative x inside of the cube roots. And when you simplify this negative, because it's a cube root, negative can be factored out, right? And this is going to give you negative f of x. And we know that negative f of x, I mentioned that's going to be odd functions. And remember, odd function is also same as the origin symmetry. And we know that cube root graph look like this, right? Cube root. So just thinking about the graph of the cube roots, we can tell this is going to be origin symmetry, odd functions, right? But this is another way of figuring out by replacing x with negative x. The second one is asking you to find the intercept. So we have two intercepts, X intercept and Y intercept. In order to find the X intercept for any given equations, you're going to let Y equals to 0. And Y is same as f of x. So when we replace f of x equals to 0, and so for x is going to be what you get for X intercept, right? You're going to cube both sides to get rid of cube roots. Then you end up getting x is equals to 0 cubed, but that's going to be 0, right? So x intercept will be 0. In order to find y intercept from any functions or equations, you're going to let x equals to 0. So when you replace x with 0, this is going to be 0. So this is going to be x intercept, y intercept, and this is odd functions. And they're asking you to graph. So when you're graphing this, you want it to mark x intercept and y intercept, right? When you end up finding only one point when you plug in intercepts, what you need to do is maybe replace few more points. If you get 2 points and you know the shape of the graph, you should be able to graph it. But because you only have 1 point, maybe we can replace x with 0. Well, x equal to 0, we don't need to replace it because we know that's going to be 0 already. What about if we replace x equals to 8 then? That's going to be 2. But if we replace x equals to negative 8, that's going to be negative 2. So when we look for positive 8, negative 8, we will get positive 2 and negative 2. Somewhere here and somewhere there, right? Draw the, and then since we know the shape of the graph, pass that 3 points to graph your graph for the given f of x functions. Okay, so then let's try another one just like that. This time we have absolute value. right? Absolute value, in order to see if it's even, odd, you're going to replace x with negative x. And if we end up getting, so no matter what sign you have inside of absolute, that's going to be same as if you have positive number, right? Which is going to be f of x. So we end up getting back where we started, and we mentioned that's going to be even functions. And if it's even function, this is going to be y-axis symmetry. Y-axis symmetry. And we know that, I mean, maybe not yet, but this is something we're going to go over, the different shapes of graph for different functions. Absolute value, you're going to have a V shape. So if you're going to have a V shape, you can kind of tell this is going to be already y-axis symmetry, right? Again, we will learn how to graph and the basic shape of different function later on. Let's find x-intercept. X-intercept letting y equals to 0, so will be absolute of x equals to 0, so x is going to be 0. Y-intercept, again, you're going to let x equals to 0, right? So y will be 0. So with that two information, all I have order to graph is going to be 1 point. So then maybe we can find another point. Maybe I will let x equals to 2. Then it's going to be y equals to 2. If I let x equals to negative 2, y will be positive 2, right? Because absolute of negative 2 is 2. Absolute of positive 2 is 2, right? So if it's 2, 1, 2, it will be 1, 2, positive. Negative 2 will be positive. So then draw the straight line, passing that 3 points. It gives you V shape of the graph. So that's how you're going to find graph. Find few points, and if you know the shape of the functions, then you can just connect those lines. The next one we have rational, right? So that one, I'm talking about fractions, right? 1 over x. Let's see what we're going to find. The first one, finding even and odd, we're going to let x equals to negative x. We'll give you 1 over negative x. You can pull that negative out. We'll give you negative 1 over x. That's same as negative f of x. So this is going to be odd functions. Don't forget, odd function is same as origin symmetry, right? And finding x-intercept, letting y equals to 0, so it will be 0 equals to 1 over x, and multiply both sides by x to get rid of fractions. You end up getting 0 equals to 1, and it cancel out x. So this, we know that there will be no x-intercept. X-intercept is not going to be 0. You get rid of the variable, right? So it will be no x-intercept. What about y-intercept? Y-intercept is letting x equals to 0. And we know that when denominator is equals to 0, that's going to be undefined, which means there will be no y-intercept. No x-intercept, no y-intercept means my graph will never touch x-axis or y-axis. Let me see if I can graph. And since I have no points, I guess I need to plug in more points than the other ones, right? So let's see what happens if I plug in 1. That will give you 1 over 1, which is 1. If I plug in x for 2, it will be 1 over 2. 3, because you're replacing it at 1 over x, right? That gives you 1, 3. If I end up plugging even smaller number, right? Like decimal, half, right? That's going to give you 1 over 2. Get rid of complex fractions by multiplying numerator denominator by 2 over 1, right? That cancels out. Denominator will be 1, which is 2. So let's see what we have. So when x is 1, it will be 1. X is 2, it will be 1/2. X is 3, it will be 1/3. I know it's going to never touch x-axis, but it's going smaller, right? And when we replace half, we notice it's going to be 2, right? So if we have, it will be 2. Again, it will never touch y-axis. It means your graph is going to be look like that and going close to x-axis and y-axis, but will never touch them, never cross them. So that's going to be your graph on the one side. But because we know this is odd functions, which means Olgin symmetry, the other side, the negative x value, even though I didn't plug in here, I know that negative value side is going to be exactly same looks, right? Exactly same looks on the third quadrant because it was the y-axis symmetry, right? So that's how you're going to graph it. Otherwise, you need to plug in like -1, -2, -3, -1/2 to find all these points, right? If we didn't know it was odd functions. Okay, we have example 5. This time they're asking you to find or graph the piecewise function. We call this is piecewise functions because depends on different domain, you have different types of equation given, right? So this is piecewise functions. They also want you to find out when x is -2y value, x is 1y value, x is 2y value. So let's try to graph them first. Order to graph, you need to look at your domain first. So here it's say when x is smaller than 1, your equations, your graph is going to fall into your function of -3x. When x is greater than 1, it will be fall into -3. So when you're finding a points by plotting the points, what you need to do is you need to get the points for 2 separate occasions. So this one is when x is smaller than 1. This is going to be when x is greater than equals to 1. Both of them, it's start 1. Even though this is not included 1, both of them, you wanted to start it from 1. So x will be 1, smaller, so maybe try 0. And because we know this is straight line, right, -3x, that's linear, so we know a straight line, we probably need 2 points only. When x is greater than 1, you started with 1 and then greater, so maybe we can try 2, right? So when you replace -3x equals to y, x equals to 1, you get -3 times 1. Your y is going to be -3. When x is 0, that's going to be 0. So you have 2 points. And then let's try the other one. When x is equals to 1, here you have -3 equals to y, or f of x, right? This means you do not have any x variable. So no matter what x value you're going to have, your y value is going to be always -3 because you cannot replace x with any numbers, right? So with that, let's see if I can graph those two. It will start both when x is 1. The first one, when x is 1, it was -3. Right? This point. But then, what do we know? This one don't have equal signs. So that point, it will start out with open circle. Right? Maybe let me make it a little bit bigger because I need to draw the other ones too, right? Okay, so let's do that a little bit bigger. So that will be this one right here. X is smaller than 1, which is not included. So that point is not included. When x is equals to 0, y is 0 will be that point. So my straight line start from this point and passing. Oops, had it to be, hold on, undo. It should be straight line, right? So look like that. The other one, second one, when x is 1, y is -3. So that's the same point. But this time, because you had greater than equals to, it means it's going to include that point. So it will be dark circle. And no matter what x you're going to have, it will be always -3, right? So it will be straight line passing that point. So it looks like it's going to be a horizontal line. And from the previous sections, we learned that when you don't have variable x, when y is equal to any number, it will give you horizontal line. So that makes sense. So this is the graph you're going to have. Right? So this is graph for the given piecewise functions. The next, they are asking you to find f of -2. So what happened when your x is -2? X is -2 is right here, right? So you wanted to know when x is -2, what will be your y value? So somewhere here, that's the points you wanted to find. How do you do that? Well, you can replace it. So when you replace it, you're going to replace it into this equations. So it will be -3 times -2. That's going to give you +6. So your y value should be +6. And then they are asking you to find when x is 1. X is 1. X is 1. We know that's going to be -3, right? And we're going to use x is 1 equals to 1. So that will be this value. What about x is 2? X is 2 will be that value, which is -3 again. So that's how you can find the solution of given expressions and your graph or piecewise functions. Example 6, let's try one more. This time what I know is that one of piecewise function, the part of piecewise function is going to be linear. This one is going to be quadratic. And they have two different domains, right? So let's go. This is going to be when x is smaller than -1. This is when x is greater than equals to -1, smaller than 2, right? So x smaller than -1, we're going to use x plus 3. So when x is equals to, I'm going to start with -1, right? Because that's where it started, difference, right? So -1. Always start from what is the given number, even it's not included, even if don't have the equal sign with it. So -1 smaller, that's going to be maybe -2. And this one was linear, right? Linear will be straight line, so I don't need more than 2 points if I'm confident, not making mistake, right? So then -1, replace it. Plus 3, which is going to be 2, right? -2 plus 3, which is going to be 1. So that will be the graph, right? So let me graph that. when x is -1, y is 2, and open circle, right? Not include. And then when y is -2, it will be 1. Straight line, right? So that will be the graph for the first part. And then the second area, again, I need to start -1, greater, so maybe 0. And I wanted to finish it smaller than 2, so I do need 2 because I wanted to make sure where the 2 is going to lies on. So always this range, you need to start it from there and end it from there. And this is quadratic, right? Quadratic will be parabola, the U shape. Let's see what we get. -1 square, right? That will be +1. 0 square will be 0. 2 square will be 4. So then let's see, -1, 1. And it's equals to, right? So make sure you use the dark circle. 0, 0. -2 will be 4. And don't forget these 3 points. Oh, and this one should be open circle because it's not include sign. It will be just smaller than 2, right? So that will be open circle. Let me erase that. Open circle. So draw the parabola shape that's passing these 3 points. Don't forget, this is not going to be straight line. It's going to be a smooth curved line connected 3 points. So that's the graph you're going to have. What else are they asking this time? -2. -2 was 1, right? -2 right here. And then when f of x equals to 0, that will be this point is 0. -1. That will be this point, which is +1, right? That's -1 right there, 0 right there, and -2. That's what we have. I hope this will help you solving different types of the piecewise functions.